Welcome to solverfy.
Looking at the list of common active ingredients found in acids for A from the list, we're asked which of the compounds produce gas-forming reactions when combined with HCl. So when combined with HCl, NaHCO3, KHCO3, and CaCO3 produce carbon dioxide gas. So those would be the three that would participate in a gas-forming reaction. For part B, we're told that 1 tablet of Tums regular strength contains 500 milligrams of calcium carbonate. So for part 1 here, what's the balanced equation for calcium carbonate plus HCl? HCl would be present in stomach acid. Balanced equation here. H2O and CO2 gas. So that would be for part 1. For part 2, what volume in milliliters of 0.5 molar HCl would react completely with 1 tablet of Tums? So 1 tablet of Tums. So 1 tablet of Tums, we're told, is 500 milligrams of CaCO3, which is equivalent to 0.500 grams of CaCO3. So let's find the volume of HCl that would react with this. Starting from 0.500 grams calcium carbonate. And let's convert this to moles here. 100.1 grams in 1 mole. 1 mole CaCO3, 2 moles of HCl, and this would yield 0.5 divided by 100.1 times 2, 9.99 times 10 to the negative 3 moles of HCl. And let's find the volume of HCl, which is equal to moles over the concentration. 9.99 times 10 to the negative 3 moles divided by 0.500 molar is the concentration of the HCl. And this would work out to 0.0200 liters or 20 milliliters. So 20 milliliters of 0.5 molar HCl will react with 1 500 milligram Tums tablet. And for part C, the active ingredient in Rolaids are calcium carbonate and magnesium hydroxide. Write the balanced equation for the reaction of magnesium hydroxide and HCl for part 1. Magnesium hydroxide and HCl. And the magnesium hydroxide would be present as a solid. HCl would be aqueous. This would yield MgCl2 and H2O. Balancing this, we need a 2 in front of the HCl. For part 2 here, we're told that if 29.52 milliliters of 0.5 molar HCl is required to titrate 1 tablet of Rolaids, the tablet of Rolaids contains 550 milligrams of calcium carbonate. What is the mass of magnesium hydroxide present in 1 tablet? So let's find from the titration data, let's find the moles of HCl, which would be equal to the molarity times the volume in liters, 0.02952 liters, and this would be equal to 0.01476 moles of HCl. We're told that in Rolaids there is 550 milligrams of calcium carbonate, which would be 0.550 grams of calcium carbonate. We can find number of moles here. So this would be 100.1 grams in 1 mole. This would be equal to 0.00549 moles of CaCO3. So we know that from part B above, reaction of calcium carbonate with HCl, so 0.00549 moles of CaCO3, 1 mole of CaCO3 to 2 moles of HCl, and this would be equal to 0.01098 moles of HCl, and this would be from the calcium carbonates. This would be the HCl in total. So this is due to the CaCO3. So the HCl neutralized from the magnesium hydroxide would be the amount total, 0.01476 moles minus 0.01098 moles, and this would be equal to 0.00378 moles of HCl due to the calcium or the magnesium hydroxide, and now 0.00378 moles of HCl, 2 moles of HCl to 1 mole of magnesium hydroxide. And this works out to 0.00189 moles of the magnesium hydroxide. And now let's calculate the mass of the magnesium hydroxide. And so 0.00189 moles of the magnesium hydroxide, and molar mass here is 58.3 grams in 1 mole. This works out to 0.110 grams of magnesium hydroxide, or 110 milligrams of magnesium hydroxide in this tablet. So in this tablet, we have found that we have, we're told 550 milligrams of calcium carbonate and 110 milligrams of magnesium hydroxide. For part D, Maalox can be either purchased in liquid or solid. 1 teaspoon has 200 milligrams of aluminum hydroxide and 200 milligrams of magnesium hydroxide. What volume will react completely with 1 teaspoon of Maalox? So we're told that we have 200 milligrams of magnesium hydroxide, and so let's find the moles of HCl based on this. So 0.200 grams times 58.3 grams in 1 mole. And 1 mole of magnesium hydroxide reacts with 2 moles of HCl. This would yield 0.00686 moles of HCl required. And we're also starting with 200 milligrams of aluminum hydroxide. And so this would be 0.200 grams. This should be MgOH2. I'll squeeze that in there. Aluminum hydroxide times molar mass of aluminum hydroxide is 78.0 grams in 1 mole. And in 1 mole, aluminum hydroxide reacts with 3 moles of HCl, 1:3 mole ratio. This works out to 0.00769 moles of HCl. So combining this together, the total HCl is equal to 0.00686 moles plus 0.00769 moles. This is equal to 0.01455 moles of HCl. And we can see here that the volume of HCl needed for the neutralization is moles over the molarity, 0.1455 moles divided by the 0.500 molar. This works out to 0.0291 liters or 29.1 milliliters of HCl. So that is our answer to part D. We are I'm going to go back to part B for a sec. We did not calculate the in part B the amount of HCl needed for the neutralization. The moles of HCl, the total moles of HCl, so I'm going to go back to part B. The total moles of HCl here is 0.001476. So back to part B, total HCl is 0.01476 moles. So the volume here of HCl is equal to 0.01476 moles divided by the 0.500 molar, and for the neutralization here in total, we get 29.5 0.0295 liters HCl, or 29.5 milliliters HCl. So for part E, we're asked which one neutralizes the greatest. So for part E, Tums we found neutralizes 20 milliliters of HCl. For part C, Rolaids neutralizes, and we just calculated this, 29.5 milliliters of HCl. And part D, Malox, we found neutralizes 29.1 milliliters of HCl. So which product neutralizes the greatest amount of stomach acid? We can see that Rolaids neutralizes the greatest amounts of stomach acid, or just acid, with Malox coming in a very close second.